So previous workflows and previous webinars that I've discussed is really the knowledge that's seen in process development and where it's being stored and where it's then being used to make those decision support. And you'll note right now in the central location, what we found from users, if they're looking at any type of workflows and process development, it's stored in several different locations. So just like you said in the poll, maybe it's stored in an ELN, maybe there's a paper trail, Excel, Word, or through emails and having those discussions, or finally some internal databases. What we found though is once they've had all this information from different users, that everything is being stored internally, maybe into a SharePoint or a shared drive. And that's where issues come up where you're not sure of what's occurring within a specific project, if you're looking at specific batches or lots, or a specific synthetic scheme. So what we've done in further or earlier iterations of the software is just we built a Luminata, and Luminata was really based upon taking all this information that's being stored everywhere else to just being placed here where you can make those types of decision support evaluations for batch-to-batch assessment, process assessments, different purge factors, just where that, let's say, genotoxic impurity is being seen. So really, that was the existing workflows that we had. But now within version 2019, what we've done is we allowed the users to have more flexibility and different workflows in here as well. Now, we'll have a series of webinars within the next couple of months going through this, but today we're going to just focus through the batch genealogy workflow. Now, why is this important? So you can see right now in the world, if you look at different cases of drugs, so if we look at valsartan from last year and looking at Zantac, which occurred a couple weeks ago, there's been several recalls, and this has a great impact. And what's happening is after all this is completed and you have all your information of the synthesis of your batches that are maybe created in-house or externally, where's that information being stored? What occurs if there is a failure where, let's say, a genotoxic impurity, such as looking at NDMA, is coming out? How can that be prevented before it reaches this level? So what we've done in this version is really try to minimize what's being looked at in the industry. So just like Matt was saying, people may be using Excel to store these type of family trees or this batch genealogy map, or they could be using Visio, or they could be using PowerPoint, but this isn't live to anything and nothing can be stored here. And that's how we really fit in this workflow within inside of Luminata. You'll note that within Luminata, now we're not looking at a synthetic scheme or a process map. We're just going through and looking at the batch genealogy of a specific project. And in this case too, we're not just looking at numerical values and looking at trends such as a batch-to-batch assessment, which we are very strong in. We can look at differing polymorphs and differing images of what's occurring at every batch level. So getting those ideas, seeing what impurities are coming out, and really narrowing down what's occurring in the lab so you prevent cases where batches are made with certain impurities that have gone through. In this case as well, what I want to emphasize here is that this screen is very flexible where you're not just going to look at, let's say, the batch map or the family tree. You can also click through and see the analytical data associated within that batch as well. And that's a crucial thing. Things internally right now, you can't link that dynamically. So if you're looking at your batch map that you have created through, let's say, different systems in-house, you're not going to be able to see the values and also see dynamically through their tables where they're occurring. Now, again, just like Matt mentioned early on, why is this important? Well, when something occurs in the lab and you have to get that information out, you'll note this is just a PDF. And if I really wanted to define where that impurity or what those values are, it's really tough to see. So really a gap in information of where it's being stored, how it's being viewed, and how to search this through. What particularly happened in specific batches or lots that made this occur where an issue arose? And again, Luminata is built on the Spectres platform of being able to import from any type of analytical data and just taking all that knowledge and importing that analytical data where you've taken in process data sets. So if you're looking at Empower or Chameleon, we're taking in all the values already done in there. You're not reprocessing anything. And now you're able to store from all these different instrument types all into one location. And that's crucial. You're not just looking at one vendor. The ability to put everything together to make those decisions, not through a PDF and not through access to all those differing systems as well. So in this part, we'll just go through a live demonstration of the software. So what I want to cover with you is really how to create the family tree. So starting off by just registering certain batches, so what they feel and what they look like, associating that with a synthetic scheme, creating, let's say, additional batches that were consumed upon with the one that we registered, and then from there, attaching analytical data, which is quite crucial. The ability to just put in that data to see it down the line. Now, lastly, what we're going to cover during this portion of the webinar is the capability of just making those assessments, such as looking at impurity fates from all those batches, maybe looking at the batch fates of how it started and where it ended off. And then from there as well, just the capability of looking at carryover values. So that's what we're going to cover right now. We'll go through that within the software. So in this case, you'll see this is a finished record. This is looking at a synthetic scheme, very easy, 6 steps. You've done this portion of it, but really down the line, what you want to do is capture more information of the batches. And what the software allows me to do is, okay, I've looked at this record. I can create the family tree. Now, in this case, it's going to use the example here that I have as a project, which is EagleMelting, which is a central nervous drug. Here, I can just type in what the name of this should be. So I'll just use the date and place that in. And it creates a screen where you can now register batches or add available batches within the software. So once we start doing that, it flips it over, and you'll see within the software right away, it takes from that synthetic scheme, changes our screen where now we can take that knowledge that we have. Now, if I had any other previous batches that I would like to add to this family tree that I'm creating right now, I can, and that's what is appearing right now on my screen. In this case, I'm just going to start from the very beginning. And the whole idea here is where we've created, let's say, a batch, and we know where it's been, starting off. So we know all the predecessor steps. So if we knew this batch is coming from previous batches, we can go there and start making our connections. So in this case, I just go and I just say, register a new batch. Once you register a new batch, I just type in the name. So let's say this is batch number 6. And I knew my previous batches. And what's nice is because it's linked to that synthetic scheme, I can choose the processes that I've looked at before. So in this case, I can say, well, this is from, let's say, this particular process. Maybe it's from this particular stage. And I can start connecting it down the line. Now, a crucial thing that we can do is have the amount of this batch that was made and place it here. So if I have, let's say, 100 kilograms, I can place that within a batch. And I can also customize it and put in all my class types as well. So here, let's say this is in the API batch. It's maybe an intermediate batch that I've taken. I can put that in, and then I can click OK. Now, once I do that, it'll just appear on my screen. So you'll note I have my batch that I have made and registered and the amount that has been used. At this point, I can further start creating the family tree. So I don't have to register anything else as well. I can just add available batches. So I'm just going to add one more batch just to show you what that looks like. And again, now instead of registering, I can just choose any of these processes. And within any of these processes, I can then attach it down the line. And the beauty of this is that we know for batch 6, let's say, where it was created from. So you can always go backwards, but with a new batch, you can't go forwards unless you have that information. So here, I'll just type in, let's say, the previous batch, and that's just 5. So batch 5, I'll place that here. It adds it in as well. So within my family tree now, I have all this information. Now, once I've done that, I can then just start drawing arrows to it as well too. So in this case, I can just go through it and start placing my arrows and start doing my connections as well. So just going through, connecting it, and also showing how much has been consumed through batch 5 and batch 6. So just that idea of just going and having all that previous information. Now, at this point, I'm just going to go to Finalize batch record so you can just see what that looks like. And once you see it, we have all of our records here. So you'll see that in this case, we'll have batch 5, and I can put batch 6 here, but we're going to see everything that was consumed from that previous batch. And what we're going to do is now finalize that and put in data. So here, I'm just going to go back, add my available batch, so you can just see that we've put in batch 6 to this finalized record. So in this case, I'm just putting to a specific stage like I had before. And then we can just draw that arrow, and then we can just start adding information as well too. So that capability, and you'll note that this is all flexible. So right now, if you are doing this in the lab, like I said, you're maybe using a different drawing package, or you're just using something in-house to draw items. Here, I can place this together and now see everything as well. So I can start drawing this through. And you'll note that this is, again, where batch 6 is being consumed. So at this point, what we're going to do is we create the family tree, and now we want to add data to this. So in the previous batches that we have here, we've already added data, but not for the, let's say, the API step. So I go to within processor, which I mentioned, where we have everything processed and taken in from the instrument vendors and placed it within the software. Now, again, the beauty here is that everything has been pre-processed. Like I mentioned, if you're looking at Empower, you're taking the area percents, maybe you're taking the weight, the ppms. You're not reprocessing those validated instruments. You're just taking that knowledge that you've already obtained previously and just putting it within the software. This is quite crucial because if you're going through this, you're going to have several different locations where you're looking at your data. And within your data too, if you're looking internally, it may be stored in one place, but also if you're working with external partners, it may be somewhere else with a different instrument where you're getting those PDFs, and again, disconnects that occur. So here, within Spectres processor, everything's already been pre-processed. I just click on the plus, and when I click that, it's allowing me to update with specific batches seen within the software. So once I update it, it's going to pull through, and you'll note these are all my batches at differing stages as well. And once I select which one, so I selected my batch 6, it's going to then pull everything through and then attach the impurities of interest to that batch. And again, I can attach everything, or maybe I just want to attach a couple at a time. So you just get a better view of what's occurring. So in this case, I'm just going to attach several different compounds so you just get a feel of what it looks like. And then it's going to go to batch 6, the one that we've registered together. So from here, it's then attaching the data. And again, this is one analytical data set. But if you have several different data sets, more chromatograms, or even if you had proton or carbon or IR data, that can all be stored within this to really build out and see what's occurring within that particular batch. So here it is finalizing its update, and it'll be stored in the background. And you'll note, nothing's being seen right now. And that's the beauty of this. In this one screen form that we're looking at, it's been attached in the background. But we're going to delve in this more detail for this family tree. So again, it's a very simple family tree. And at the end, I'll show you something very complex as well. So here, if we're looking at batch 6, you have all my tables associated with it here. If I change my screen form, you'll note that we have several different screen forms. I can click here, and then when I click on my differing screen form, you can see the data associated with that as well too. So that here within my batch level, all my analytical data and everything that's been processed previously. But again, let's go back into to other screen forms so we can just look at our values and look at what's occurring within this one family tree. Now, the first thing we're going to do, you'll note that within every batch level here, I can actually show the structure or to show the names. So for simplicity, I want to show you every impurity associated with every batch. And you'll see here down the line that now that every batch level has increased. So you see every impurity there. So in this case, if I zoom in further, just here, all the impurities associated. And what's nice is if I draw out any previous arrows, any of my impurities seen here as well too. So just the idea of what impurities are there and what's occurring. Now, if I zoom back out, what's nice about this is there's several things that you've seen in other webinars. If you have seen in my webinars and within Luminata is you can just look at specific impurities. So now, right now, if all these arrows here, if I just click on one of these impurities, I can also just look at the impurity fate. So if I select this, I see some arrows have disappeared, and now we just focus on this one impurity down the line. So if I remove that, you'll see some arrows come back as well too. So again, the capability of just seeing the fate of a specific impurity. And just note, if you had, let's say, a genotoxic impurity and you want to see that it's been removed at a specific batch, specifically if you're looking at a drug substance, API, or drug product, you can view that here. Now, another thing that we can do is also look at the carryover values as well too. So if I just take this and just see the carryover values, you'll note again, I activate my names and I can select the impurity of interest. And just like what you've seen before within my previous webinars, I can select and just say show, I can just click here and just say calculate carryover. And you'll see down the line all my values. So the speed of just going through and getting those purge factors are quite fast. Now, again, when we go through this notion and we see all these values, other things may arise too. Just like I mentioned, you may not be interested in analytical data. You may be interested in also just what did that batch look like. So within the software here, we can also view down the line any of the, let's say, the polymorphs or the images within those batches. So previously attained for, let's say, a specific batch, I've already attached in the image where you can go through and start looking at specifically different stages of those batches and what's occurring completely. Now, again, for yourself, there are several tables. One table is to calculate carryover that we saw. We have this one entity table that's quite familiar for our users if you're going through it. And we also have your batch impurities table. And within your batch impurities table, you can start doing direct comparisons to see where impurities lie. So just by clicking on any cell, I can just say, well, I want to filter this content. And when I filter this content, I can look at specific batches. So if I start looking through and do a direct comparison of a batch, I can choose, well, what do I want to look at? So if I wanted to look at a couple of batches in this list to get more information, let's say from where it ended at batch 6, the one that we registered, and maybe how it started off, I can just look at these two differing batches. And when I click that, you'll note that this impurities list will say that it's been filtered down, but down the line here, you can just start looking at what impurities are seen. And that's a crucial thing, is that you may not know what's occurring, but you can actually do a direct comparison and just see those values and see where those batches are seen and what impurities are seen here. Now, again, I can filter this down and I can start adding other impurities as well. So if I just go through, say, batch 5 as well, and you'll note that once I start adding batches, I just want to see where these batches are obtained and what their values or their impurities and their relative area percents are occurring here as well. So the capability of just seeing this. Now, again, this is a very simple case. So let's go to something very complex so you guys have a better feel of what's occurring. So this is a completed family tree of EagleMelting. So here, down with EagleMelting, you'll note this gets very complex. And again, you may have not seen, but EagleMelting is a 6-step reaction. And what we did down here is just made all these steps at different stages, from step 1, 2, 3, 4, 5, and just going down the line. And in this case, again, you're doing the same type of filtering. You want to know what's occurring, but not only are you filtering down the impurities, you can also see the batch fates. So specifically, if I wanted to go to this batch in the middle where it's being connected to several different routes and batches that were completed either in-house or externally, it's quite difficult. And the more complex it gets, the more difficult it is to see where that batch started from and where it ended off as well. So again, what the software allows me to do is take my dynamic information that I have here, and I can select this, and I can just say show batch fate. And what you'll see right away when you do this is that everything gets hidden. So you can just imagine, this is a more complex case, but if you're in industry and you have to make any type of family tree assessments, or you're getting, let's say from your CRO companies or CMOs, their external batches, this is quite difficult to see. And again, those cases, you may have all your drug substance batches, but you may have all the other drug products. The ability to just show that one batch fate to where it's being consumed, where it started off from, is quite a valuable tool for any end user just to see and get those values together. So to end off, it's really that information that we've all been storing and all those different locations and the capability of just taking those values that you saw within my table, and they could be numerical values, non-numerical values, and making those batch-to-batch assessments where you can really be preventative of any issues that come up when you're actually creating these batches in-house and externally as well. So really taking everything that you had from the bench to the boardroom and making those types of development decision support within the software for your group. So again, to summarize this, Luminata helps teams prevent transcription errors. A big thing that you've seen with the webinars for Luminata is the capability of just taking everything that you've already done and placing it in one central location so these failures and these issues do not arise in the future. So organizing all relevant data to save time and keep projects on track. and assembling live data critical for efficient control strategies. So in this case, the control strategy to really minimize where that genotoxic or impurity is being seen at a specific batch in a central location where we can make those types of decisions right there. And really from design to data to decision dissemination, leveraging everything that you have into Luminata where you can make those decision supports capabilities.